Okay. So the future of innovations would be in the interface of science and engineering, as I mentioned. Sir, can you see the slides? Okay,
Yes.
fine.
Yes,
The,
yes.
okay, the term convergence is commonly used in reference to synergistic combination. Example, voice telephony, data, and video onto a single network. These are previously separate technologies and are now able to share resources and interact with each other. So if you look at this biotechnology, many key elements of the vast human nervous systems exist at nanoscales. So the pigment molecules in the eye that make the vision possible, the vesicles that store neurotransmitters, just a few examples of nature's work at nanoscales. And if you study understanding of the targeted drugs depends on nanoparticles as carriers. The whole mystery of the human genome and the way by which knowledge is encrypted is being revealed systematically using computers. So now if you look at the cogno, computers would be used in sensing, perceiving, memorizing, actuating, and controlling, and in continuous learning. I'll come back to continuous learning a little later. Sensing element that will play a critical role will come from nanotechnology. The machine mimicking human activities in large scale will become, has already become a reality. Neurobiology, brain machine interfaces will be the key technologies. All of them have been demonstrated already. And some of the current experiments in cognition science, our ultimate aim is a good thing is, can we capture the mind of social and antisocial human beings in digital form? Looks possible. And convergence, what we say about convergence is the line between living organisms and the machines has just become a lot more clearer. And to many of us, it has become a lot more murkier. European researchers have developed neurochips in which the living brain cells and silicon circuits are coupled together. This achievement could one day enable creation of sophisticated neural processes to treat neurological disorders and so on. Silicon implant mimics the hippocampus, an area of the brain for creating memories or in the anvil. Silicon implants have changed the field of healthcare to health repair. There are many more, a new world of excitements. In other words, this is the world where the God-made systems and the man-made systems symbiotically merge. Personality capture is another thing which has been a lot of research work which has gone on, and I will tell you about singularity as done by this thing. If the predictions for someone's mother dies in 2050, the digital mom captured by the technology will be 50% her. By 2080, it will be 80% her, so that you could stand in front of her like a knowledge amplifier, ask mom, this is what has happened in my life, what I should do at this time. You could interact with her the way you would have done it with her physical twin. And expanding human cognition and communication, improving health and physical abilities, breaking physical abilities through non-therapeutic means, acting as barriers commuting groups and humans and national security. So the overman, as defined by Ray Kurzweil, is the advent of new form, and in relation to the same new modalities of the overman, neither human nor God. Hello, Dr. Chaudhary. Dr. Chaudhary, please switch off your mic.
Yeah.
Okay. There is a hope in the overhuman. This form that stems from a new play of focus located outside of the human, in the revenge of silicon over carbon, of the generic components over over the organisms of the, argumentative over signifier, you know, outside the human. So Deleuze wrote the following rimbaud: man who is even in charge of the animals, a code that fractures fragments from other codes. So this has actually happened quite a few times in our this thing. The singularity, we are entering an era of singularity. It is when humans transcend biology. So it's a merger between human intelligence and machine intelligence is going to create something bigger than itself, either the machine or the human being. It's a cutting edge of evolution on our planet. One can make a strong case that it's actually the cutting edge of the evolution of the intelligence in general. It's a search of immortality of humans and even the globe. The next stage of this will be to amplify our own intellectual powers with the result of our technology. Today, we actually amplify by very many things by about 100 to 1,000 times our human capabilities using the computers, the internet, and so on. So the Ever Learning Society, he started in 2029. He says that it will start. The learning constitutes now primary focus of the human species. The human learning is accomplished using virtual teachers, virtual libraries. We have already pandemic has, preponed it quite a bit. Learning is enhanced by widely available neural implants. That is, you have implants and so on. I'll talk about that a little later. Automated agents are learning on their own. That's called the cognition amplifiers. I mean, without human assistance, and they keep reminding you, oh, your flight is on time, your flight is delayed, and so on. Machines can create now significant amount of new knowledge. That is the recognition part, not the recall part. The older machines used to recall the information that it had seen before. So you all of you are familiar with Alexa. You could ask millions of questions to Alexa and you get a very good answer, a friend in need. Of course, there is a never-ending learning by Tom Mitchell, a good friend of mine in Carnegie Mellon. It actually continuously learns. Now, if you do the Google search and ask for who is the president of the United States, it'll even say Barack Obama because the Google messages do not have timestamp. The temporal evolution of the knowledge is not there. The timestamp there is the time at which the information was posted. So here it actually, based on ontology and various other competing things, it builds a knowledge graph. It knows that today Barack Obama is not the president, but he was the president during which time and so on. It learns continuously. And any of you must look at this. Auto text to knowledge conversion is also part of this never ending learning. And so NEL, the inputs to NEL, an initial ontology defining hundreds of categories, person, sportsman, your name of the town, the fruits, emotions, and the relationship. This is the graph, knowledge graph. Given these inputs from a collection of about 500 million web pages and access to remainder of the web through search engines like APIs, NEL runs 24 hours per day, continuously takes the thing. Today, we have technologies by which a computer can memorize or go through the entire syllabus in maths, physics, chemistry for an 8th standard student, answer questions, and beat a student in the actual examination. Extract new instances, categories, and relations, learn to read better than yesterday. And this is the basic thing. At present, NEL has accumulated knowledge base of millions of asserted instances of thousands of different categories and relationship. It has been growing. IBM's Watson, many of you are familiar with. I was fortunate enough to have my son and my daughter-in-law work on this. And Watson was named after the first CEO. It could actually go ahead and play Jeopardy and do play chess and so on. Beat really great human beings who are well endued in that. Dr. Abhijit, Dr. Abhijit, please switch off the mic. Okay, thanks. Harnessing intelligence from many sources. You have big data intelligence, cross-media intelligence, crowd intelligence, augmented and unmanned autonomous vehicles intelligence. Now let's see how we make use of this in what we call as it's a practical systems already implemented called the guardian angels and cognition amplifiers, augment intelligence of the humankind. Many of you are familiar with the guardian angels. So I have my own guardian angels on certain topics. I can ask them questions and they will give me an answer for what it is. But the guardian angel of mine is a software, an agent that keeps continuously learning what I need. Continuous monitoring of sensors and new smartphones enables activity monitoring, often subsets of humankind, and activity patterns of the users. What is my behavioral analysis? In fact, in security today, the network behavioral analysis, one of the common terms that's used. Earlier, it used to be used only in the human beings. Intention awareness, creation of personal guardian angels. Now we have a guardian angels for every person and a guardian angel for every activity of the person. And you know, the GATS and COGS enable automation. The maximum is activity monitoring, intention awareness, and enables GATS and COGS. And these are the two. Thousands of GATS and COGS help each person on the planet. It doesn't have to be just one single guardian angel. It's autonomic, always on. It continuously learns. Humans usually not in the loop, and conserve human attention and multimodal communication among the cogs. Between the cogs, there is a good this thing. The guardian angels are examples of the use of artificial intelligence 2.0. It also uses the crowd intelligence. If you look at this is the CMU cog um, architecture. It uses subject matter experts. It could also learn from machine learning agents and crowdsourcing. It could actually throw a question to a crowd like a, mechanical Turk and get a response and perform and keep advising you continuously. So the impact is NBIC has several implications to the society and national prosperity. It will enable complex systems that are man-made, as complex as the God-made systems. Most biological systems will be engineered, as I said. The whole doctrine will send us look for solutions from social sciences, biology and nature, and not from computer science. This will herald a new revenge of silicon. The convergence, just to summarize what I talked about, we are all familiar quite some time back. Computer and communication technology converged, became ICT. Nanotechnology came in, and you started talking about intelligent silicon, um, intelligent silicon waveguides, modulators, switch detectors, and so on. And we talked about integrated silicon, electronics, and photonics materials convergence. And then sensors came in, radio on a chip, ad hoc sensor networks, intelligent roaming, and so on. Cyborgs and so much these things. Once the biological sciences joined, that's the cyborg we are talking about. The humans, which are more than 100 to 1,000 times more efficient than what we were. The man Ray Kurzweil is one of the greatest visionaries that I've seen in computer science. He first wrote a machine called Age of Computing Engines. Then slowly he wrote a book on Age of Thinking Machines. Now later on, 1990s, he wrote a machine called Age of Spiritual Machines. His idea is a complex collocation of atoms, carbon atoms, like a human being, could do computing and thinking and become spiritual. Why can't it happen? Because of the complex collocation of silicon atoms added with artificial intelligence. This is one of the best books, but he has written many other books after that. That is the Ray Kurzweil's the Overman, and many books are there. So this is how it happened. You know, you are going to be bearing many of these things. So there is a wallet which has got a sensor, and it says wallet gone, but when somebody steals it, it also has got a sensor on the shoe. It says crib. The curb is appearing. Approaching. Be careful, and your necktie is tighter, and so on. This is how the interactive wear is going to be. It's already there. So people in the beginning said only humans can play baseball. Today, I play baseball with a computer. Only people have common sense. Now today, computers have more common sense, and they are consulted in artificial intelligence. And only a human can review a movie, computers do. In other words, all of the things that we talked about, that the only humans can hear, computers start hearing. Only human can talk, computers talk. Only humans can write plays, computers do. And then you slowly become, they do everything that the human being does, and much more efficiently. In socio-technical world, it's only natural you talk about social networks, not just the network of computers. Health repair instead of health care. Silicon replacing carbon, and the coexistence of silicon and carbon. Inability to distinguish between people in the network and the computer in the network. Social network of people, social network of computers, sleeper modules of terrorists. We have sleeper modules of zombies in the Trojans and botnets in the computer network and so on. So if you look at this, this is what Ray Kurzweil asked. If you're a carbon-based complex computational collocation of atoms, and we are conscious, why would the same be true of sufficiently complex silicon-based systems? Today, silicon-based systems can be as spiritual as we could be, except replication. I think most of the things can be done by uh, the man-made systems. That is the inevitable birth of artificial intelligence. The research agenda, as I told you, they merged completely the online world and the physical world. That's because of the revenge of silicon. The physical world has also become the same size as the complex man-made systems, so they could actually merge quite easily. And psychology can give insights to usability, deception, larger scale uh, social networks. We may be able to learn interesting lessons from many other sciences. The big challenge to understand how to manage the evolution of complex socio-technical systems. All of us are familiar with complex socio-economic systems. Social networks, analytics, machine learning, and the complex mathematics and supercomputing. That's what others call it data science. All this triggered by revenge of silicon. And we there are other people who are great followers of carbon, and they say, okay, don't worry, Balki, there is going to be a new thing. Graphene is coming, and it might actually put, you know, carbon in its correct pedestal, and it's about 0.142 nanometers could be the possibilities, and still in the work on the anvil. That's what is science about. One revolution pushes another, and that continuously. So our work, I'll just talk one slide and then complete it. Our work actually, because of the fact that we work on information security, we started looking at these advances, started seeing these kind of evolutions in the networks and in information security. We started in 2003. We started enhancing ideas using deep learning and deep neural network in those days using sensor fusion. And we started using this, all of the neural networks and other machine learning technologies for malware detection, botnet detection, social network analysis, malware classifications. And today, we are at the pinnacle of what we call as an explainable AI. In other words, if I ask you, what is the solution to this problem? You will say this, and you're not going to keep quiet. I can ask you questions. Why are you saying that? You can explain your decision. The computers were not doing that till now. So the explainable AI has started now doing this. And this is a great science because a good amount of mathematics is involved in that, and it's quite interesting. Just to give you an analysis of what we have looked at, botnets is a social network of computers. Terrorist networks, we have tracked almost all the terrorists who are actually associated with bomb blasts in the country. They are a social network of people. Lack of credible information due to covetousness. Same thing with this terrorist network also. And most importantly, the knowledge about the network is local, like ant colonies and so on. They don't know the global picture of it. So does the botnet network. It only knows one hop or two hops away. And terrorists also know only one or two hops away. They don't know where the command structure is lying. Spread through trusted network of compromised hosts. Same things. The terrorist networks also do that. Steal personal information, mainly for financial gain in the botnets. Attacks to fulfill common political agenda is the terrorist analysis. So if you look at the behavioral analysis of all of them, the modeling that we do artificial intelligence, they're identical to both of them. So just in order to conclude, ICT is a technology for the society, as I mentioned. It'll draw upon advances from all branches of science, engineering, and will seamlessly merge with them, and also social sciences, nanosciences, and biological sciences. These were not known earlier.
Very
We all
interesting.
thought
Both interesting here, Kouchanti.
when it merges with society and biology, it will become as complex as God-made systems, which is already done. The two worlds would merge symbiotically. Silicon will slowly and steadily replace at least functionally carbon. As I started with the topic, revenge of silicon in the social technical world is very complex. And as I said about our idea is to make you more efficient by 100 to 1,000 times than what you're today. The future computers will do more than computing, tend to look more and more like humans, from calculating engines and thinking machines to spiritual machines, as I mentioned. Your computer will start to look more and more like human. And now they say that you already have started to build a relationship with your computer, which I mean even your cell phone. If you don't have your cell phone, you feel some certain amount of itching in your hand. So you start missing it. Seamlessly move between you in the physical world and you in the cyber world. Digital physics is the subject which started about 10 years back by a good friend of mine. As you know, computer science is based on, physics and natural sciences are based on laws like Newton's laws, Boyle's law and all that. The laws have to be obeyed without any exceptions. Whereas computers do not have any laws. They have lemmas and theorems. So now the digital physics, when these two fields merge, we are talking about areas of computer science having not only this thing, lemmas as in computer science, and the digital physics will have both theorems, laws, and lemmas. That's the way by which the future is going to look like. That physics is going to be slightly different from the physics I learned in school. My family is very big, more than about 65 students graduated out of my lab. For masters and PhD and so on. And the contribution of all of them, I just put a word jumble. And I just want to really thank them for each one of them had contributed at different parts of their career with me. And it's a pleasure talking to you. Thank you very much. I would be happy to answer any questions if you have. Thank you.
Thank you, sir. Thank you so much for elaborating, explaining the topic. I would like to invite questions from the audience by raising their hands. It will be helpful, or they can put up the question on the chat box.
Yes. Yeah.
Go ahead.
Yes, ma'am.
I was next.
Yes, you can unmute and proceed.
It's now about this. I am Dr. Patnaik. I work as the Dean in the veterinary faculty. The talk by Dr. Balakrishna is very, very exciting. I was wondering if the silicon replaces carbon in a glucose molecule, what is going to happen? So finally, it is really exciting. One query, Dr. Balakrishna.
Yes, sir.
What is the future? What is the future of artificial intelligence? We are doing it for what? Finally,
No, sir,
what is our dream? What is our dream? To make food for me, or to win a war for me, or to write a book for me? Finally, what do you aim at?
no, sir. I'll give you a simple example. You are a very highly acclaimed dean and you are a very good teacher. It's extremely difficult for me to replicate you. And there are several universities would benefit by your presence. So if I can create an artificial intelligence and mimics what you do, and you can stand like never ending learning, I can stand in front of you, ask you a question, sir, if I mix this chemical with this chemical, what will happen? You will say Damal like this. But that is the recognition, not the recall. The books will be able to give you a recall capabilities. So basically what happens is you need experts like you on problems which we have seen already, on problems which you have not seen. So that is the kind of role that will play. For example, there are also some tasks which are very mundane. For a simple example, granting loan in a bank. There are certain if then else rules, you tick, 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 tick. And that is very boring for a human being to do that. And it is a, superb waste of his time. So I could actually go ahead and make use of an artificial intelligence thing. It could go ahead. Then based on the experience of whether the loan became a non-productive asset or not, I can actually go ahead and learn and correct my algorithms. So there are lots of important things. For example, a doctor's image analysis. Today, the most highly used artificial intelligence packages are for that purpose. Whether I have cancer or not, from the radiology med reports, how to do that. So that expert cannot be available all over the place.
Yeah. But sir,
I would like to invite
one more query, sir.
this.
Since the year 2000, since the year 2000, we are seeing irregular occurrence of pandemics. Say it is SARS, bird flu, swine flu, or now it is COVID. It is occurring frequently in a frequent occurrence. Say in 2000, 2020, we have 6 pandemics. So how the AI is going to help us in predicting the future pandemic? Say this coronavirus pandemic, we know coronaviruses are omnipresent. In all species they are there. They are in human beings, they are in pigs, they are in bovine, in poultry, in cat, in dog, in fish, everywhere. So how
Sir,
it is going to help me to predict the future
artificial,
pandemic?
artificial intelligence is not the elixir of life, not everything. Number two, even today, all the models that you see for the projections of the pandemic, they're all AI based. Most of them are AI based, and they're not time series analysis alone. They're complex artificial intelligence models which have come. So it also the controllability of those things are also AI solutions, which the government has used, and very successfully to a great extent, we have been saved from being wiped out. Okay, so AI is not going to answer everything, but it will be useful for you. That's all.
Thank you, sir. Thank you so much.
Can I ask something? Hello, can I ask something?
Yes.
First of all, it's nice to see Balakrishnan after a long time. I remember
Thank you, sir.
so, sir, in two places, I'm slightly confused, or you may, you know me, so you know in the line I talk. I always talk in terms of system. So you are trying to correct a system. That system, maybe human system, maybe any technological system, it has an input as an output. I'm talking, from my Kalman filter background. So if you have to measure these two things, then only you can do the intelligence properly. So sensors is the key to solve your problem. What is happening? We are only giving mileage to the softwares, but we are not giving that much of importance to the sensors. Sensors recommend, and that one which Nonaman started in ARCI. He was the only director, but he died. That's a very bad thing. Actually, I was going and trying to help him. So sensors, we have to push more.
Sir,
Without this, I
sir,
want to have your view.
actually, in one of the slides, I had sensors as the first thing. In all of this, sensing is the best one, the first
Yes.
starting point. And I said also, quite some time back, silicon and its siblings were not considered as very efficient sensors. Now they've slowly become extremely good and they could get integrated. I said that in one of the slides.
That's very good, sir.
I
Second
gave
question.
one, sir. I also
No,
talked about wireless sensor networks, wireless sensor
yes.
actuator networks. I built it like that.
And second question, it's slightly personal. My daughter is working in a different field in the bioengineering, and she is working on gene therapy. So
Right.
I'm trying to learn from her, and she got a startup project from USA. So
Okay.
she is setting up one company in New York and one company in Hyderabad. I
Very
was
good, sir.
surprised to see the. Please visit that Central University. You tell me anytime, I'll tell her. Central University Biofin has a very good facility. Everybody is hiring. So I'm finding they are also facing this problem of sensing. But I find they have defined all of us as 32 GB data. That is, Balakrishnan is a 32 GB data, Dr. Chaudhary is a 32 GB data. Only our array points are down. Their main problem is safety. Instead of correcting brain, they may correct the stomach. So that gene and their correction, that is the main challenge, and she has taken up that. So I was saying it is not only the sensors, but how to use and get the correct information, which is important. I have just this point. I thought I will
Sir,
add to your.
I have one great advantage. if I have the data, all that I would do is I call one of my students who is probably a university rank holder somewhere. He will come and solve the problem.
But
Okay, so
I thought it's better to exchange in this fora that biosensing is another thing which is must, because we are, somebody told me just now, the problem is disaster management. The disaster management is in environment or in the human being. So two kinds of management we are do. Disaster is all in the environment and all these things, and the other one is with your body. All of us, I also got corona.
thank you, sir. Thank you. I'll take note of that. And any more questions, madam?
Good evening, sir.
I,
This is, am I audible, sir?
Yeah.
Yeah.
Hello. Yeah, good evening, sir. This is Shanti. I am an IISc alumni, and I'm really glad to be in your class once again because you have been our beloved Balki sir all the time.
Thank you
So
very much.
thanks a lot.
Now,
Thanks a lot.
Shanti, you are the
Yeah.
fourth person from IASA I'm seeing in this crowd now.
Okay, sir. Okay, so
And Dr. Sundaram is also there. He's a very senior person, of friend of mine. And
okay.
so that makes it, at least five.
Yeah.
Go ahead, Shanti.
Yeah. So my one statement and one question. So I was one of the very fortunate persons in IISc when Sahasrat was first installed, and we literally had to convince the Sahasrat team to open up the queue of 44 GPUs for my genome sequencing algorithm to be run. And thanks a lot because we could generate 3 granted patents out of that with Professor Nandi and Professor Pal of IISc. So that
Very
is
good.
one thing. So would love to, get access to the Param Pravega also to continue those efforts, And so, I mean, I know you are the person behind all those efforts when IISc initially started
No,
off with the
it's we're
supercomputing
very
venture.
happy, very happy. I tell you,
Yeah.
you know, I started my computer usage with a machine which had 64 kilobytes of main memory.
Oh, okay. Okay.
Okay. And 100
Okay.
of the students at the Indian Institute of Science, including Samir Brahmachari, myself, all of us were using it.
Yes.
Today,
Okay.
we have a 3.4 petaflops of machine, I mean, computing machine, humongous machine.
Yeah.
And you are always welcome. There is a very
Thank you, sir.
standard policy for outsiders to use it.
Yeah. So the only thing I miss is that I'm not anymore as IISc student who has a legacy to get onto that
No,
with a
no.
lot of
Where,
pride.
where, 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 where are you working?
I'm now an associate prof with Shivnadar University. Uh,
Oh, then as an academic, you can ask them.
okay. Thank you, sir. Thank
And
you.
you should
Thanks
have
a lot.
you should have done something more.
Tell me, sir,
We also
please.
fund humongous number of projects
Okay.
for
Okay.
furthering research using supercomputers.
Oh, okay. Okay, sir. Okay.
Okay. And the next call for proposal when it comes, see, for example, many small universities in Kerala, in SRM, AP, all
Uh-huh.
of them have been funded to the great extent of about 60, 70 lakhs, and they get free
Okay.
computing time as well.
Oh, okay. That's really great, sir. Definitely.
You,
Next time
you,
when the call opens, I'll definitely apply.
you contact Bhishma Pita there, Professor Damodar Acharya, he will tell you how to contact this thing, or
Sure, sir.
yeah,
otherwise send me balki at iasc.ac.in.
Definitely, sir. Definitely will do. Okay.
I'll direct you to the current in charges.
Yeah. Sure, sir. Thank you. Thanks a lot. So now the
well,
question, we are working on explainable AI. So in that, I'm trying to come up with with a measure for the recognition part of cognition. So can we
No,
have, I'm trying to answer this question, like, just like how we have
you send
emotional
me the
quotient.
details, I'll tell you.
Yeah.
Okay, right?
Yeah.
It is either are you're looking at global or local explainability, then
I mean, it's a mix of both, sir. So it's like,
mix of both. And
yeah, it's both. Yeah.
I will send you, there are 3 papers which I recently wrote with my students.
Oh,
Or
definitely, sir.
the best would be, I would put you in touch with one of my students. We just finished 3 papers,
Oh, wonderful, sir. Wonderful.
okay,
Okay,
on
definitely.
explainable AI, and
I'll definitely write, sir. Definitely write to you.
write to me, and I will
Yeah.
put you in touch with a student. Her
Okay.
name is Sweta.
Okay.
She has worked on the measures for all of these local and global explainability,
Oh, okay. That's really nice. So
both
my
for
own.
random forest as well as the deep learning networks.
Oh, okay. That's very nice. So random forest was one thing that I was specifically interested in. So that makes my job like, I have something to refer to in that area now. So,
Right.
sir,
I will put you in touch with them.
yeah,
And
definitely.
you're a biologist, is it?
My background is ECE with an interdisciplinary PhD in genomics and computational biology.
Okay. Because
Yeah.
okay, you said send me. I'll send you also 3 of our papers in biology now.
Oh, definitely. So
Okay.
one term that we were trying to coin there was a measure for the cognition coefficient. So we are trying to come up with how much cognitively able an network is. So will that be a good thing
That's
to work on?
absolutely. There are measures which are available.
Yeah.
Actually,
Yeah.
Google people have done a lot of work. You write
Yes,
to
sir.
me. There is something
Definitely.
called a transfer control activation vector (TCAV).
Okay. Okay,
That
sir.
will give you many of them. Send you a video of the talk by the lady who actually invented TCAV.
Okay. Thanks a lot, sir. Thank you. Thank you once again for a wonderful talk as usual. Thank
Great.
you, sir.
Okay.
This is Ajit Sapre. Can I ask a question?
Sure, sir.
It's a wonderful talk. I'm not a computer science. I'm just a chemical engineer. But my sense is that a lot of the AI ML today is really dependent on a huge amount of data. So in some sense, it is more like a pattern recognition and pattern filling. And I know that unlike the human brain, which can contextually adapt, when all this cognification, everything is wonderful. And what is this explainable AI?
Sir,
It's
I
a good
just
idea,
wanted.
but when you
I
don't
want
have
to
any
stop. I
data,
want to stop you
how do you
there.
do it? Yeah.
No, I want to stop you there. I have 2 sons and 2 daughter-in-laws who are PhD in artificial intelligence from Carnegie Mellon. I must tell you, you have trivialized every one of the efforts of everybody. It's not that simple as pattern recognition. Okay, I rest my case. No, no, no. I mean, it's like, I mean, it is something where I did disregard due to this thing because the field has grown so much, sir. I don't think you have an appreciation of what it is. It is not. It is you. You can't talk in a meeting like this, like what a Hindu paper does.
No, I guess what my thinking was is artificial
Right.
intelligence is more
It's
like an
okay. I
is
mean,
it not? This is not more like an
I mean, you have a right to your argument. I mean, your thinking,
no.
but
Isn't it
that's
more like an augmented intelligence?
no, sir. It is an artificial intelligence augments things. There are millions of work which are available that does that. Okay.
Yeah, thank you.
Sir, can I ask a question?
Okay, sir.
I'm Sanat Kumar. Uh, basically, I'm a mechanical engineer working in reactors. And I
Very
am,
good, sir.
so this question maybe I'm not very sure whether it is very relevant or not. You talked about carbon and silicon, but
Right,
what
sir.
about germanium? Somewhere does it come? Germanium
Ah,
comes?
no, sir. What happened was even when I started my electronics in 1973, we studied germanium and silicon with equal emphasis. Okay, sir. But somewhere down the line, because of its inability to integrate, to give yield large scale integration and so on, germanium dropped out of the race. Originally, when I said, PNP and NPN transistors, we talked about we were taught with both germanium and silicon because so one had an excess electron, other one had a valency gap it had. So you could either inject an electron and make it positive, or you could take out the electron and make it make it positive, or inject an electron and make it negative. So it's a semiconductor. Both germanium and silicon are very good semiconductors when I started my electronics. But slowly over a period of time, nobody talks about germanium because of its inability to integrate to large scales and feature sizes coming down and so on.
Thank you, sir. Thank you.
Any other question?
Yeah. Can I ask?
Sure, sir. Go ahead.
Yeah. This is RK Singh from Atomic Energy again. I have 2 questions. One is, how do you see the self-repairing robot development that happened in a space program and the present day technologies which you mentioned with the machine learning, AI, and perhaps modern biosystem towards realization of the fittest to reproduce? That was the theme of your lecture highlighted in the beginning.
I haven't understood the question, but Even in the networks, we have self-organizing networks and self-healing networks. And they are based on concept of AI only. They're no different from that.
Okay, and my second short question is on the symbolic computing, because many problems were unresolved and symbolic computing was coming in a big way earlier. So what is the present status, and can we have some complex problems which are unaddressed through this route of this symbolic computing?
No, so symbolic computing, you should know where are we using it for. For example, if I'm using it for actually natural language processing and so on, those kind of things, it will be very helpful, but not necessarily in AI and so on. Not that I know of. AI
Okay.
is basically a data intensive computing models.
Okay.
There is a complex network, deep neural networks and so on. They learn from. Now, the original difference between AI and any other system is that earlier you had S is equal to UT plus half AT square. That's the equation. You had the model and you had the data. Now I don't have the model, neither implicitly nor explicitly, but I have the data which I observe. So from that, I keep building the model. Okay, because of that, there are very interesting things happen. It is not the laws where 100% satisfaction is necessary. Here, sometimes they work. That's why you call recall, precision, and all of those things and so on. Okay. Any more questions?
Thank you.
Sundaram, I just want to say, I'm like Sanat Kumar. I'm a mechanical engineer of the 50s who was taught computer programming by your brother Ramani in 1772. And today, you've taken us to an entirely new level of what we have still to learn. Thank you very much, Mr. Dr. Balakrishnan. Thank you very much.
Thank you, sir. Coming from you,
I'm 87.
I'm coming from you. I really cherish that, sir. Thank you. So, Dr. Sundaram
yes,
is Mr. Agni. Okay, he is also from the army, but he came and did his PhD at the Indian Institute of Science, quite a few years my senior and my brother's contemporary. So, thank you, sir.
Thank you, Balakrishnan. Thank you so much.
Sanat Kumar has raised his hand.
Yes, Dr. Sanat Kumar, would you like to say something?
So by mistake, I think he has. I would like Jayashree Madam to
Jayashree
ask.
Ratnam is actually raised. And
yeah. Good evening, Professor Balakrishnan. Actually, we met in CMU. I am the wife of Professor Ari Rajkumar at IIT Bhubaneswar.
Oh, thank you.
Okay. So this is a rather naive question because I'm not really into computational engineering at all. So what caught my attention is about silicon systems getting spiritual. That's what you refer to as one of the possibilities of futuristic breakthrough technologies. But we already have a very rich spiritual tradition in our culture. So why not, instead of getting into the future, is there a way to decode the past scriptures from these technologies?
Oh, there are lots of work going on in that direction. But
already, Universal Digital Library and all certain things were done already.
Yeah, we have also done a lot of work, but actually the final answer in all of these things is not so easy to come out. Okay. That's why those problems are much more interesting. If I had said the last word is said in that, then there is no interest in science in that. Okay, so it is, I mean, the scriptures are very complicated encryptions. Yeah. And people like Dr. Sundaram will know the decryption is much tougher task. Even today, with all the computing power that we have, it's extremely difficult for us to break the 128 code, 128-bit, this thing, asymmetric encryption that we do for our banking. We still use it. It's very tough.
Okay. So
It's like,
another question which I had, I mean, before the one of the speakers, one of the professors earlier raised that. So is it really silicon or the semiconductor which is going to be the future? Because gallium arsenide, so the group 3, 5 component, I
yeah,
mean,
all of them were there.
elements are all going to have a
No,
lot of.
they are very good for different applications. Okay. And for example, indium antimonide, if you're actually wanting to detect infrared, that will be very good.
Yeah.
So, but in terms of computing, CMOS technology and all of them, I think still silicon,
Yeah, there of
not
course,
only
yes, silicon.
when you say 3-5 semiconductors, as we call them generally, they're all there. But it is understood now, transistor means silicon. Okay, all others are, they've come and gone, but they have found many applications. So even today, if you want to make a microwave amplifier, they're nothing like gallium arsenide.
Yes.
Okay, so there are applications which are there for 3-5 semiconductors.
Photonics is there, and then quantum computing, is it relying heavily on silicon again, or again a combination of? Because quantum
Actually,
computing is something.
it is again photonic. You can have silicon photonics as well. Okay, but we are not the experts for quantum computing. So I must apologize beforehand. Okay, it is a vast change in the way by which we think itself. So.
But definitely, it's going to help a lot in your futuristic computing here. Right. Thank you, Professor Balkrishnan. It's nice to listen to you.
Right, thank you very much.
Thank you, Professor. Now I would like to invite our Pro Vice Chancellor, Professor P.K. Nanda sir, to thanks to Professor Subramanian.
Thank you. It's quite actually a privilege and also gratifying to listen about for a century of evolution about the right from 70 to 2070, what is expected about the computer science and the convergence of bio, nano, and cogno. That's quite very interesting and exciting, really exciting lecture for all of us. And not only that, Professor Balkrishnan could also envisage and open a new vista of kind of, I think there will be a machine which will be mimicking the creativity because cognitive is embedded into it. So I think there will be a lot of creativity component which will help to address a lot of issues. And also I appreciate the challenges he has thrown upon maybe for a decade or so. So on behalf of, I think it has really been beneficial to all of us, and it's quite kind of sweet presentation and a lot of thought-provoking questions, and also the whole evolution put in a capsule form and told in a particular hour for all of us is very, very beneficial. On behalf of Bhubaneswar INE chapter and behalf of Sikha Anusandhan University as well as IMNT, I'd like to extend profuse thanks to Professor Balkrishnan who could spare his time to share his expertise and vision before all of us and answered many questions. And we, I think, aspire to look forward to listen such lectures from you, sir. Thank you very much. I also like to thank our Director Professor Basu, our Honorable Vice Chancellor, and Professor Damodar Acharya, who is steering this kind of programs, who is actually engineering this program, and our coordinator, Dr. Renu Sharma, who is coordinating behind the scene, and all the distinguished, I think, professor, academicians, industrialists, and fellow, I think, all engineers who have participated here, and I think it is beneficial. It's a really marvelous and wonderful talk today you had. Thank you very much.
Thank you, sir. Professor Manna has come and he raised his hand.
Yeah, so well, I mean, you noticed me, so thanks very
Manna,
much.
would you like to add something?
Yeah, Professor Acharya, I was about to seek your permission, and I actually, I had something, so I couldn't join on time. But when I finally managed to join, I could see only the last slide saying thanks, and such things can happen only in India. So, but I was very
keenly listening to the conversation. Thank you very much, Professor Balakrishnan. I mean, you certainly are a legend by your own right. And this particular initiative of Professor Acharya and Bhuneshwar chapter is really a very laudable one. And I'm very glad. So on behalf of INAE, I thought I would just thank you for.
Thank you very much, sir. It's a great pleasure to see you.
Right. Thank you.
So, Professor Balakrishnan, it is really a great pleasure and honor to listen to you.
Thank you, sir.
Your inputs. And one or two small things that I would like to put it. Thank you very much for all these things. If you permit, can we really share this recorded thing to among the people who have participated?
You can do that, sir. You can do that. Absolutely no problem.
Okay, thank you so much. And one more thing, what I'd like to say, that on behalf of this chapter, a small memento will be sent to you. We are not able to hand over physically, but it will positively reach you. And we look forward to your future participation in this series of seminars.
Sure, sir. Great pleasure.
Thank you.
And thank you, everybody. Thank you very much. Thank you.
Namaste.
Sir, I can log out?
Oh, sure.
Thank you. Bye-bye.
Thank you, Professor Manan.
Bye. Bye.